Good morning. This is Kenneth Wong for DE 24/7. This is part of our December 2021 Industry Leadership Profiles, with many manufacturers exploring the use of 3D printing or additive manufacturing as a manufacturing method. It's time to address some new questions about the technology, which started out as a prototyping technology. So today we are speaking to Benny Bula, founder and CEO of Velo3D. Benny, welcome. First of all, I'd like to congratulate you on becoming one of the companies named by Fast Company magazine's world's most innovative manufacturing companies of 2021.
Thank you so much. It's a pleasure being here.
Benny, now that we are talking about innovation, let's start off with that. What do you think are the latest innovations happening in the additive manufacturing or 3D printing industry?
So I think the most important innovation that is happening right now in 3D printing is it is not a secret that the most interesting segment of additive manufacturing is metal additive manufacturing. This has been growing extremely fast in the last decade, and metal additive manufacturing has the promise of having a dramatic impact on a large number of industries, really disrupting those industries. And the thing that makes metal additive manufacturing so interesting is that it has the promise of making very complex shapes and very complex parts, allowing designs to be pushed to places that you couldn't push them before. However, the problem that we have seen in metal additive manufacturing is that the parts that would be the most exciting parts to try to apply metal additive manufacturing for are those parts with very complex internal structures, parts that cannot be machined easily, and parts that typically are welded or brazed or cast in a very long manufacturing process, and in many cases manufacturing process that are limiting the innovation and what you can do. Those parts that are the most interesting to do is metal additive manufacturing generally have not been manufacturable easily with metal additive manufacturing. And we'll expand on this later, how people try to overcome that. What has been brought to market that is really changing it on its head and really allowing a new wave of innovation in additive manufacturing is manufacturing technology that actually was pioneered by Velo3D, which allows the production of these most complex parts without having internal supports in those parts, allowing the creation of the most exciting, most interesting parts people thought of applying additive manufacturing for, but that for decades were not possible to manufacturing with additive manufacturing. So what we really see in the last few years is the coming to age of additive manufacturing as a technology that solves real problem for end use customers.
All right, let's clarify a little bit about those support structures, Benny. Usually when you print a complex part, in order to hold the piece up until the print job is done in the print chamber, you need some kind of support structure to keep it propped up. And at the end of it, removing that is an additional job. And in Velo3D's technology, is it a different method? Is there a different way of removing it?
Yeah, so the important thing is it's not that we have a different way of removing that. We do not place those supports there to begin with. And the problem with those support structures is not that it adds labor and that it costs to remove them. And it's also not the fact that it costs additional manufacturing costs to produce them. The problem is that in many of those cases, really in the most important cases, the supports are in places where are impossible to access and impossible to get them cleaned properly. So the problem is that the supports actually prevent the production of the most useful parts. It's not about cost, it's about the impossibility of making the parts that you really want to produce. And in the case of Velo3D, our support-free capability allows us to eliminate the need of those supports to begin with and making the parts people really need.
Okay. People talk a lot about a skill that is now called D for AM, design for AM. And that's a skill that is in some engineers have because they have to think about how a part is going to be 3D printed, but not necessarily all engineers are trained to do that way. What is your recommendation for firms that want to take advantage of additive manufacturing, but don't necessarily have internal experts with design for AM skills?
Yeah. So in my opinion, design for additive manufacturing, or DFAM, is the most important single enemy of additive manufacturing. And the reason for that is because people have been talking about DFAM in an extremely disingenuous way. DFAM is maybe 20% design enabled by additive manufacturing, basically allowing you to do things that you couldn't do with previously possible methods or previous methods. But 80% of that is design constrained by additive manufacturing. Basically, how do you make things, how do you design things that can be produced by additive manufacturing? And the problem with that this portion, this design constrained by additive manufacturing, is the really challenging things to grasp, is the really challenging thing to learn. And that's what requires a lot of retraining of the engineering force. And the other problem with that the utilization of this constraint and the design that is constrained with those limitations is resulting in a tremendously compromised parts, compromised performance of the product that you're trying to make. So the problem here is that it's very difficult to teach something that is not true. And it's very difficult for people, for engineers, to accept these design principles, because it's very obvious to many people when they are presented with these limitations, that those limitations are not free, and they present a significant compromise of the product. So really, from our perspective, the solution is not how to overcome the gap in DFAM, but to completely eliminate this dependency on DFAM. And the manufacturing technology has to be such that engineers can actually design the parts they really need, and then being able to make the parts they really need, and not constrain those parts to what is manufacturable with commodity or legacy additive manufacturing. And this is really what we brought to the market. So in the way we view it, companies that do not have these internal experts for design for AM are blessed.
So Benny, the way I see it, there are two possible ways to overcome the DFAM issue. One is, of course, you come up with a kind of printer that can accommodate any kind of geometry, no matter how you design it. The other one is using a kind of software or firmware that alert you that the geometry that you are designing and attempting to print is likely to fail. What is Velo3D's approach for overcoming this or bypassing this issue?
Yeah, so our approach is predominantly the first one that you mentioned, is making the machines and the production process so capable that the design for additive manufacturing is not a big issue anymore. The problem with the second approach of alerting you when you are breaking the capabilities is that there is a lot of gray zone in those capabilities. And the important thing is that even if you know that you are breaking these capabilities and now you are designing in a way that you will not break them, you compromised your product in this process. It's not the same product.
So let's talk about the evolving use of additive manufacturing now. It started out as a prototyping technology for printing out one functional prototype for testing and form, fit, and function. But now a lot of people are thinking about using it to print hundreds, thousands of parts by the hour. What are the important preparatory steps that firms need to take first if they want to go that route?
So as you are trying to create this solution in your company that would leverage additive manufacturing using a supply chain, what you need is to pick a solution that allows you a scalable supply chain. And one of the things that is really important about a scalable supply chain is the ability for a design to be produced in exactly the same way on different machines in different suppliers, getting exactly the same outcomes. And when you look at the legacy additive manufacturing technology, the commodity additive manufacturing technology, what you see is that companies, different contract manufacturers, utilizing the same machines, use completely different recipes, resulting in different outcomes, and outcomes that are different in ways that are difficult to perceive. There is an element of artisanship in the way the supply chain is using additive manufacturing. Again, one of the things that we did that is very different, as part of our complete solution to provide additive manufacturing solution, which includes the print preparation software, the printers, the quality control, and the underlying manufacturing process. Once you locked a design file, this design file will be manufactured exactly the same way on all our machines in all the different contract manufacturers, providing the same outcome. And that's an extremely important element in the establishment of additive manufacturing as a volume production technology, because it allows you the creation of this supply chain that can scale, and it can scale very quickly.
On-demand manufacturing or contract manufacturing was an important part of the struggle in the last a couple of years when COVID was causing a lot of supply chain disruptions. And we thought that the COVID pandemic crisis would be over by now, but with the Delta variant and then the Omicron variant, we may be looking at new supply chain disruptions. What do you see as the role of additive manufacturing going forward?
There are elements in the supply chain that it takes a lot of time to turn them up, because you need significant capital investments, people investments, as well as very often the lead time on those is very long to increase capacity. Additive manufacturing, what we see in the industries that we are participating in, as we aerospace, energy, power, and semiconductor, is that additive manufacturing allows the creation of a much more agile supply chain, a diverse supply chain, and a copy exact supply chain. The copy exact element is very critical, that you can get from different suppliers in potentially in different continents exactly the same output with exactly the same digital file, regardless of who is the contract manufacturer that makes it. And that's an extremely powerful, I would say, modification to our supply chain. So what we have seen in the last year, in 2021, that in all those industries, there are very extensive efforts to use additive manufacturing.
Benny, thank you so much for spending time and answering my questions. I really appreciate it.
Thank you so much. It was a pleasure.
All right. Until next time, ladies and gentlemen, this is Kenneth Wong for DE 24/7, and we are out.